Since I don't know why nothing has been said on it yet, sir. I've been checking Twitter, I've been checking everywhere. But I think Starknet has some, is undergoing some breaking changes. I don't know how many of you have been following the whole news so far, but Starknet is introducing privacy, like Starknet is going private full time with the whole Ziki and everything. How many of you know about it? So as a result, I think uh has anybody tried to deploy anything today? If you have tried to deploy anything today or even maybe yesterday, nothing has been working. So in case you were having errors, I'm just telling you why you might have been having errors. Anyway, what we have for this week is composability and components. And we introduced it on when did we introduce it? It was on Monday we introduced it. So what I said is that sometimes, can everybody hear me? Okay. Sometimes when you are writing smart contracts, it turns out that you want to use the same contract for many things. Let's say I'm writing a smart contract for a whole company, right? Like this contract is going to be basically the company's book. Like it will have both records of all the members, it will have their financial records, it will have different things concerning the company. And the same contract will be in charge of disbursing salary when it's time for payments. I've actually written a smart contract like that. Now, when I happen to be writing that particular contract, it turns out that the logic for that thing, you can divide it. Like it's possible to separate different parts of the logic. There is the parts where you are handling addition of members, how sacking, promoting, doing different things to members. That's like the member manager. There is a part where you are handling um, income and expenses. Like it can actually be in the same contract. You handle people paying money, people, the company sending out money to do something. You can handle a whole lot of things. And at the same time, there is also a part where you can handle like scheduling of payment and all that. So when you are writing a smart contract like this, if you do everything in one file, the way we did it that first day, the way we wrote our contract that first day, you find out the file will be very, very big, right? Am I correct? Please responses. And apart from the file being very, very large, the code is not going to be that readable because before you to understand a particular piece of logic, say it depends on different other pure functions, you have to be scrolling and scrolling, you have to check where this is. It's going to be like very, very annoying to actually deal with. So one solution that can be explored in that situation is the use of components. Now, components are building blocks. They are like, as it says here, they are like Lego blocks. They help you enhance your contract by plugging in different models so that you don't, first of all, when you use components, there are plenty of advantages of using components. First of all, you don't have to put all your logic the same place. Secondly, your components are actually reusable. Like you can write one particular component and use it in, say, three different smart contracts in the same code base. In fact, there are a set of written components, like pre-written components on OpenZeppelin. People plug these components into their contracts and enhance functionality. So these are the kind of things components do for us. You actually, and okay, one of the principles people apply in writing code, you should also apply, is that you should keep your code dry, right? You should not do not repeat yourself. That's the meaning of dry. Don't repeat yourself. So when you have a particular thing that you want, that you have to do, say you're writing more than one contract now, and you have this particular logic that both contracts are supposed to use. You don't have to implement the same logic separately in both. If not, you are repeating yourself. You can just do it in one component and use the components across both of the contracts. So yeah, that's how it is. So the difference between components look very much like contracts. The only thing is that components are not standalone, so you can actually not deploy a component the way you deploy a contract. Instead, in order to use a component, you have to embed it within a contract. Any question before I move? Is everybody following what I've talked about so far? Okay, I'll take that as a yes. Okay. So a component is very similar to a contract. It can contain, of course, it uses interfaces just like a contract. It has an implementation block. So it's obvious, and it can implement logic of internal and external functions. So it's exactly like a contract, except that you cannot deploy a component. A component has to be embedded inside a contract. That's so okay. And we used the bookstore we're building the other day. John, also you have something to say? Okay, no, that was good. Okay. We used the bookstore we're building the other day. I'm just going to open it here. A Skillup bookstore. Can everybody see my screen? Okay. Sorry. Let me enlarge my display. Mm. Is it better now? I actually believe it is. Mm. So in this contract, if you can remember, everything was previously inside the lib.cairo file. Okay, just okay. This is originally how it was, right? Right here we have our contract. Okay, this is the interface. This is where we define our book structs. add book, remove, borrow, return, get books, and get book. Okay, the name of our contract was Skillup Bookstore. We did all of this within this file. Now, what I did in the last class, what I basically did, first of all, I created a folder in this source. I called it contracts, created another folder, called it components. This is just how I like to structure my code base in case I'm going to add other contracts or other components to this code base. So as one of the contracts, I have bookstore.cairo here. So what I just did is I cut everything here and pasted in this bookstore.cairo. Save, save. Now, one thing that you must note is that when you are writing the Cairo smart contract, your lib.cairo is your entry point to your contract. So everything that the compiler is going to recognize has to be referenced in this lib.cairo. If I build it this way, it's going to build an empty contract for me because I don't have anything inside this file. I'm not even sure it's build as a matter of fact. Well, I'm not willing to try it. So what I'm going to do is, since what I have here is public, in fact, it's actually not about that. I have this, based on the file structure, I have a contracts folder and a components folder. So I'm going to expose this contracts folder so that if I want to reference it somewhere else, I can. So pub mode contracts. That's the folder, and then I'll open it. Inside the folder, we have pub mode bookstore. And then pub mode components. I've not put any Cairo file inside. So let me write a new file. I'm going to call this file what component should I build? I'm going to call it enable.cairo. And from this contract here. So I'm not going to add extra functions to this. So inside this component, pub mode enable. Only when I do this will the compiler recognize that there's something inside here. It's like my compiler is not happy with me today. Starknet interface, org traits, I enable. Remember I said that the components or actually also uses interfaces. In fact, it does exactly the same thing as a contract, except that it can be deployed. And then there are certain things that there are certain decorators that and types that are different. But we are going to see all of them here. Usually, is anybody with me? Does anybody have any questions so far? Any question?
James, sir, please, where did you define the components in this?
I have not defined it yet.
Okay, okay.
Okay. Any other question? So if I were writing a contract, at this point, I'll do like this. Starknet contract. And then I'll say pub mode enable components. Right? Sorry, I'm just going to restart my VS Code here. Because I love when my compiler is supporting what I'm doing. So this is how it would be if it were a contract. But it is not a contract. The compiler still does not want to support me. So what I'm going, so okay, that's shouted. So a difference here is going to be, instead of contracts, it's going to be net components. And then just the same way as a contract would, it should have a storage. So port structs storage. I'm going to store owner, and it's going to be a contract address. But I have to import to use Starknet contract address. Is that okay? Any questions so far?
GM, sir. GM,
GM?
can we go back to that,
I can hear you.
code base? No, I need to show you now so that you will be seeing it.
So what?
The code base we just left now, the code where we are writing code. This before you wrote use Starknet double colon contra address, you had first write as storage. I don't know why did you have to go back to write the use Starknet.
Because the contract address is not a native type. So I have to import it before I use it. If I remove it, the compiler is going to shout at me.
Okay, so we're supposed to like add the use attack Starknet before the storage, before the storage.
Yeah.
Okay, so
Any other question? Okay. So other things a contract we usually have, a contract to have, although not compulsorily, events where you can derive, drop, and Starknet events. And this is going to be an enum that must be named events. Let me say, let me implement stroke ownership ownership transferred. And I'm going to say new owner should be a contract address. So as the event here, so you see that components can also emit events. Component lives, they act exactly like contracts. You use them to extend your logic. But another difference is that, remember that in week 3, I taught you that there is a function that runs at deployment. Like whenever you are deploying the contract, the function is the first thing that will run, that will define the base of that contract, how the contract is going to start, the initial states. And what's that function called?
The constructor, I think.
Exactly, the constructor. So since a component cannot be deployed, a component does not have a constructor. Do you understand? Very good. So the next thing is the implementation block. So let me say I'm going to call this enable. Okay, I'm going to call this enable. Right? Sorry. Before I use the interface, I'm going to import it up here. So use super. What this super does is it just goes outside the scope. I've not even put anything inside, just imagine. Okay. Function transfer ownership. contract address. And the same way here, I have to import this contract address because it's a different scope. In order not to bloat this, what I'll just do is, since I've imported contract address up here, I can also get it down here using super. So contract address. What else? Function owner. This one is supposed to help me see who the owner is. And it's going to return a contract address. What else? What else do I want? I think these two should do. Okay. Let me start by implementing this two. So usually there is a decorator we put on the implementation block when we're writing contracts. It's the ABI embed v0, right? Am I correct? Yeah. But no, that's not how we do it in components. In components, we say embeddable as. Then you put the name you want to use to reference it. So I'm going to use ownable implementation here. Then this is another difference. What are the differences we've listed so far? This is number one, Starknet components instead of Starknet contracts. No constructor, embeddable as instead of ABI embed v0. And another difference is what we refer to the self as. Is anybody with me? Just imagine I've passed yourself. Okay.
Yes, Chief.
So okay, I've done this. I'll add renounce ownership. Sorry, let me just add it. Renounce ownership. So okay, we've talked about the interface, right? We've talked about defining storage and events. And then the implementation block is quite different. Usually, what we do in contracts is that we just come here. What is it? Okay, it's I ownable. So I'm not going to say ownable of I ownable, and I'm going to write contract states here. And then it's going to show that I've not implemented everything. But components don't work like that. You can see that it does not have the contract states. What it has is something different, which is the component states. And this is not even the same way we write it as we write contracts. So what's going to be here, right, is okay, this components is meant to be reusable, like it's meant to be used within a contract. So the contract state it will have is going to be derived from that particular contract where it's used. If it is used in two different contracts, then in each of them, it will have different contract codes. They'll be like completely different things. Are you getting me? Is anybody following? I believe so, sir.
Comment, please.
Sorry?
Come
Any
again,
question?
please. I didn't quite get you.
I said, if you write a
Like
component
just
now, can you hear me? If you write a component now, it can be used within two different contracts. It does not have the contract state here. When I wrote it, they said type not found, because whatever state it will have is going to derive from the contracts where it is used, not from itself. So even before this, one thing that we have to do here, we have to mark it with C contract states, or I explained it here that we can actually use anything and use these house components, C contract states. And then you come here and say component states, C contract states. Okay. So just learn this pattern now. Sometimes components have dependencies, but I think I'm going to talk about that on Friday. Like they have other components that they depend on, dependency components. But we are going to visit that one on Friday. No, actually tomorrow. But this is the pattern. This is the pattern for the type components carry. First of all, after implementation, open the angle brackets and add C contract states. Then this plus house components, everything, you are going to see everything in the Cairo book. Most of these things you don't have to like have them in your head. You can use your head for better things. Just hold on. Let me send here. This is the Cairo book. Just do them over again. They just naturally come. And if you never have the chance to remember them, the book is always there. I'm a lazy programmer, sorry.
James, please, is the Cairo book, is it downloadable?
It's yeah, there's actually a downloadable PDF for it. Okay. So I'm just going to add each of these things. Oh, sorry. These three functions. I stored the owner, right? Yes, I stored the owner. So everywhere here that I have T, or where I usually have contract states, I'm going to replace it with component states wrapping C contract states. See, it has disappeared. I'm going to copy it from here, put it here, and put it here. Are you with me? So for the person to transfer ownership, it means that he has to have been the owner of the components initially, right? Definitely. So the first thing is okay, let owner be equal to self.owner.read. And I just realized that I've not implemented my Starknet storage. Okay, it can actually read it without this. So, wow. Let's caller be equal to get caller address. And I have no choice here. I have to import this. Oh wow, it imported it for me. Ah, wow. I'm loving this new. There was an update to this Cairo 1.0 extension, and it's just behaving like Rust now. I'm loving it. So assert owner is equal to owner, and if they are not equal, I'm going to say color not permitted. Do you understand?
Yes, Chief. Chief, does that mean that deployment issue has been fixed?
I doubt. No, it has not been fixed.
Sorry.
Mm, it was getting so good. Pointer right access. So this has worked. And then I'm going to emit the event self.emit ownership transferred and new owner. Any question? I don't believe. So here, self.owner.reach. And here, oh, what is this? Wait, hold on. What is this thing again? Okay. For then to denounce ownership, I'm going to transfer it to the zero address. Owner dot right. Let's zero address. Hold on. So this is the zero address. I just formed the contract address from zero, obviously. So to renounce ownership, I'm just transferring the ownership of the contract.
Um, are you there, Chief? Hello?
Jam everyone, is the class still active? I can't hear I can't hear voices.
Yes, the class is still active. Just give him a moment. His network got frozen, so he will soon come back online.
Thank you.
So can anyone hear me? I'm really sorry for that breaking connection. My network here is not smiling at all. So I'm assuming this is again, this is not exactly how the ownable component is. This is just my example. Then the next thing we are going to do a what was this called? In order to use these functions, you notice that there has to be an owner. So we need something like a constructor. So a way we can do that is write internal functions using the generate traits. So I'm going to say internal implementation of internal traits. Component states, C contract states. Mm, sorry, hold on. Let me check the cairo. Okay, okay. So this is not supposed to be like this. So initializer, I can put this F, so when I use, I don't know if you learned it in previous class, but when I use this generate traits decoration, I actually don't have to write any interface for it. But this generate traits, what's here is not going to be exposed when the function is built. So it's going to be used only within this function. So in the initializer, I'm going to use an owner. I'm going to initialize the component to an owner, and the owner is going to be of type contract address. So I'm not going to say self.owner.write owner, and then maybe I'll emit the ownership transferred events. Then next, say I want to have I want to assert that the owner is the caller. Although this, let me just mm, the network. Let me just do it for the sake of doing it. But in the real components, this function is actually there. So don't mind me. So I'm just going to return this. If you understand what I'm doing here, this, or if you don't understand rather, this comparison here is going to result in a boolean. That's it's either be true or false. That color is equal to the owner in the storage. So what I'm effectively doing here is that if the person calling the function is not the owner, right? This is going to be false. And I can actually use this to panic any function. So I can come to this place and instead of doing this, I'll say instead of doing this, I'll say assert, right? Assert only owner. Okay. Self dot assert only owner color. This is supposed to work exactly. So what I've just done here is that this is an internal function that belongs to this component. So I just called it inside here. The assert only owner is going to return a boolean. And we know that inside this assert, all we need is the condition, which results in true or false. So what this thing is doing here now is just that it's checking if the person calling the function is the owner of the contract. So I need the assert only owner here, and I need the assert only owner here. I even forgot to implement it. For a person to renounce ownership, he must have been the previous owner. So I'm going to do it here again. Self dot assert only owner and color not owner. Exactly. And then I've written my components. So I'm going to come here and make sure, okay, this is exposed here. So the next thing is I want to use it within my contract. Are you getting me? Yes. Any questions so far? Any question on this component before we use it within our contract? Any question? Okay, I believe everybody is okay. I'm just going to go over this very fast. So that if possible, we are going to do inter-contract interaction before my battery gives out. Okay. The first thing I want to do is I'm going to import the components. So there is more than one way to do this. Components enable. I'll leave it at this. Okay. Enable components. I have imported the components. So in order to use it, I'm just going to come here and say components path. The path is ownable components. Storage is ownable, and the events, I'm going to call it ownable events. Now the compiler is going to complain because this does not exist and this does not exist. So the next step is, okay, what I'm doing, what I've done here is, what this line does is, it says we are going to use a component inside this contract, right? The path, that's where we are getting the component from, is this ownable component that we have imported here. The storage is going to be recorded as ownable, and the event is going to be shown as ownable events. Remember, I said you cannot deploy a component, you have to use it within a contract. So I'm going to have to add it to this contract. Sub storage v0, I think. Is that correct? Yes, it is. So I'm going to say for ownable, and it's going to be ownable components storage. So what I've done like this is now that I've taken the storage. I've used the storage of this ownable components. I have added it to the contract storage. That's what I've done here. The next thing is to add these components events to the contract events. So I'm going to come here inside the event enum, ownable events. I'll use ownable components events. So I've gotten its events here, and it's always advisable to use this flat. So this is how it's going to be. This way now, the component is ready for consumption inside this contract. Then one more thing, I have options here. Depending on, look at this. Remember I said what this does is that it chooses whether to expose the functions inside this implementation block or not. So if we don't put the ABI embed v0, when we build, we're actually not going to see this. We're actually not going to see all these functions here. You can use ANG to check it. You can remove this line, scarp build, check the functions present. I assure you, you are not going to see any of these functions. Put it back, build again, you are going to see the function. So if we want the functions that are implemented here, this transfer ownership and renounce ownership, I want them to be external, like I want them to be usable from outside, to be callable from outside. So I'm going to do this. Enable this. Is this going to work? I must have made a mistake here. Oh, contract states. Exactly. So I've passed, this is these functions here. These functions that are inside here now, this transfer ownership, owner, and renounce ownership are now available within this contract. I have embedded the logic from there inside this contract. Do you understand? Is there any questions? Is there any question before I continue? Is there any question? I'm surprised, sir. Then I can actually get the internal implementation. Enable. Is anybody still in this class even? I seriously hope. Okay, you are in the class. So why are you not replying now? So what I've done is that I have also gotten the internal functions here so that I can use them. Now, if I want to use any function from this at all, I'm going to say self.ownable. So watch this. Instead of, okay, if I have this, I actually don't need to have this storekeeper inside here. What I can do is, in fact, let me remove the storekeeper. I'm going to remove the storekeeper. I don't know why my compiler is not shouting yet, sharp, but self.ownable dot initializer storekeeper. So what I've done now is that I've initialized these components. If you remember that inside this initializer, I replaced the constructor of a regular contract with an initializer. Here you notice that I did not put any guard like to check if the caller is the owner or anything, because this is going to run at deployment, and this initializer is the function I want to use within the contract constructor when I'm deploying. So I'm not going to put any of those guards on it. And the address that I supply here is going to be the owner, of this. Do you understand? Uh, let me just, the storekeeper, I've now made the storekeeper the owner. So what I'm going to do now here is, after let caller equal to get caller address, instead of these two lines, I can say assert self.ownable dot assert only owner, and I'll supply the caller, and then I'll give my error message, caller not permitted. Does anybody understand what I've done here? Does anybody have issues with what I've done here now? I feel like there should be questions. Is Samuel the only person in this class? Now, wow. And here, I'm also going to do the same thing. Assert self.ownable dot assert only owner, and the address I'm going to pass here is going to be gotten with get caller address, and I'll give my error message, caller not permitted. What have I done? Okay, I have not done anything. So we have been able to use a component within a contract. Okay, let me just open a code base. To show you how I used different components. In fact, it's the precise example I was explaining before the class. Well, you can see it in fact here. There are different components that are available from OpenZeppelin. There is ownable, there is upgradable, there are plenty, there is there are plenty access, there are plenty components. If I'm going to send the link to the site and I'm going to show you how to use components from OpenZeppelin. So in this contract, there are different different sections of logic I needed to implement. So instead of writing everything inside one file, look at this file. This file is already 300 lines. Imagine writing all the functions. I divided into different components. I have admission permission manager. I have DAO controller. I have disbursement components, member management components, and so things like this are what you need components for. Also, you can use components like upgradable components. You don't actually need to write your own ownable components. It's available on OpenZeppelin. Okay, this is OpenZeppelin here. I feel like okay, let me send this. Let me send this to the chat. The components here can be used in your smart contract. Every component there is battle tested, so you can be assured that when you're using components from OpenZeppelin, they actually don't have, or they minimally as little as possible loopholes. It's actually better to reuse them than to write your components from scratch, because it's always better to not reinvent the wheel. So if you come over to this place, there are different components that you can actually import. Okay, this is the component section. And okay, uh, okay, so it will serve you good if you come and read these things from time to time, especially when you are using them. Oh, this one, okay. This one is ERC2981 component. There is an ERC20 component, ERC721, all the just how could I not mention all your different ERCs are they exist in OpenZeppelin as components. So instead of you writing an ERC20 contract, for example, you can use OpenZeppelin's ERC20. Apart from that, apart from components, you can actually get interfaces, you can get different things from here. Like if you are writing a contract and you need help, whether it's be it interface, be it pattern, whatever, you can come to this site. Although, okay, have I sent this? I've sent it. So when we want to use components from OpenZeppelin as part of our dependencies, just like I did here, you have to add OpenZeppelin. So I'm going to come to our bookstore. I'm not going to use the only component that I wrote again. I'm going to use the one from OpenZeppelin. So I'll just come here, add it to dependencies. Right? And then where did I import it? Instead of this, I'm going to say use OpenZeppelin. Compiler, stay with me. It's I've not asked safe. Is anybody following what we're teaching here? Is anybody like lost? Any question? Sorry for not asking for that long. Okay, let me go ahead and close this. And close this actually. I told you I like my cairo 1.0 suggesting for me. So I don't want to keep everything in my head. I'm supposed to see red because I've commented this out. So until I see red, I'm not going to write anything. Complain, complain, complain. If it doesn't complain in the next 10 seconds, I'm going to go ahead. Yep. Hmm. Exactly. So these are the different things I can get from OpenZeppelin. So this one has to do with access, ownable, and it's the ownable components that I want. Okay. Okay. Um, what's the difference? Where did I? Okay. Okay, and this one is called. They didn't put a hyphen before. Exactly. This is how the initializer is in the component from OpenZeppelin. What other components does the compiler have? In its assert only owner, its assert only owner does not need a caller. It uses the get caller address directly, I think. And then it actually does not need this safe. It panics internally. So this is just what I'll use. So this is actually sufficient with their own version of the ownable components. I'm also going to do the same thing here. So that's the difference between, so now the component I've used, sorry. Let me use it. The component that I have used is completely from Open Zeppelin. I didn't use my own local component here. Do you understand? Like, if does anybody have questions? I'm very sure you have questions. There was the thing that you are wondering how they happened here. What are your questions? Ask them now or ask them later. Ask them now, please. Nobody has any question. Chini Daniel, Dasola, Izuchukwu, Bernard, thank you. Bernard, do you have any question?
No question, no.
Sir?
No question, but let me see your code.
Okay. Oh, sorry, let me close this. What part of the code are you interested in?
I just came in now. Like, I just want to look around.
Okay. So what we have done is we used an ownable component from Open Zeppelin instead of this is the same bookstore we were writing before. So instead of needing to store the storekeeper's address inside our storage, we used an ownable component from Open Zeppelin.
That's like doing npm stuff, like importing stuff from npm library.
Exactly. This is the line where we imported it.
Okay.
And then we imported the trait as well.
Great.
Since Cairo 1.0 does some of this for you now. And then after importing it, the next thing is use this line components, specify the path. Since we have imported it, we can just put this ending. If we had not imported it, we'll just write Open Zeppelin colon access enable like that. But we have imported it already, so we put just this last one. Then specify its storage and its events. So for the storage, you can call it anything you want. Just make sure this name rhymes with this name here. That's all. So if I decide to not call this storage enable, to call it Wilfred instead, I only have to make this Wilfred. And the compiler.
What does the enable component do?
The enable component, what it does is that remember that there are certain functions we want only the owner to be able to call. Like we want only the storekeeper to be able to add a book.
Okay.
Exactly. So instead of we're going to get there, sha. Then the next thing is the events. Put the events here. I named it ownable events, right? So the next thing is to put it here, and it's ownable component dot event, just like this one is dot storage. After that, the implementation. I want to expose the functions. So above the external functions, I put ABI embed v0, and then this is the internal implementation. I did not expose it. So here, where I was previously calling let caller equals get caller address, and where I was asserting that the caller is equal to the storekeeper, instead of having these two lines, I can just say self.ownable.assert only owner. This will handle it for me. If the person calling it is not the owner, the function of panic. Same thing happens here. Do you understand?
Okay, yeah.
Exactly. So I hope you are going to go over the video and even implement what I have implemented here. I think this is like very easy.
It's just it's not for.
Is it okay? Any question?
No for now.
Okay. Any other person? I hope that explanation actually touched many lives out there as well. Any other person that needs a question or that needs to be clarified on something? No. Disappointing. I'm in the mood to answer questions. Anyway, oh wow, 38% left. The next thing I want to do is I want to briefly touch interaction between two contracts, right? So I'm going to use a student locker. And I know it sounds crazy, but this is going to be a student locker.cairo. I'm just going to implement, I'm going to put like, I'm going to put just 2 or 3 functions in this. So what I want to do is that since this is a bookstore, right? Is anybody following me? I know it sounds crazy, but hear me out. Hear me out. Since what we have here is a bookstore, when a book is borrowed, eh? When a student borrows a book, the book enters the student's locker. And when a student returns the book goes out of a student's locker. When the students say the student is missing these books and the student wants to get a book, the student needs to get the list of books that are in the bookstore. Are you following me? Like, am I making any sense? Okay. Then, so what I'm going to do is, I'm going to, this student locker that I'm implementing, I'm not going to write the logic, like, I'm not going to write the logic independent of itself. The contract is going to be calling this contract. Remember, I said in the beginning, I don't know why I'm talking like I've been here for ages, like I'm Jesus or something. But I said in the beginning, in week 3, that every contract in Cairo has the capability to act as a wallet. Like, when I mean wallet, it can store value and it can actually trigger other contracts. Like, to interact with the smart contract, normally you need a wallet. So it can actually interact, it can act fully as a wallet, like it can interact with other contracts and it can store value, as I mentioned before. So let me say list bookstore books. This is going to be a read function. And then the compiler is no longer with Misha. One more thing I'm going to do is types.cairo. So within these types, I'll come to the bookstore. I'm going to cut this and I'll paste it here. Then I'll come back here. Okay, I'll come to my lib.cairo first and say pub mode types. It's even completing it for me. Once I remember I said everything your compiler will recognize has to be in this file. So once I've put it here, the compiler actually recognizes it, and I can say use create. I can either use create or I can use something else. Book. I'll import book here, and everything is fine again. Oh, another thing I have to do, I have to say pub here so that all those features will be available. Because the error I got is this blah 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 not available in this context. So I have done that. I put this here so that I can actually reuse it. I'm going to use the same thing here. Oh, oh, the compiler has not left me. I accused it wrongly. It's because I have not put this inside my lib.cairo. So I have to add it to this place. I'm going to say pub mode student local. Exactly. And now it's showing me that I have errors here. I'll go to the beginning and I'll say use. Oh, I said you can either use create or you can use the name of the contract. So the name of the package here is Skillup Bookstore. I can instead of saying use create, although it's easier to remember create, I can say use Skillup Bookstore, and the same thing comes out. Do you understand? Yes, I believe you do. It refers to the same thing. Okay, function get a book. Book ID is going to be a U8 and function return a book. No, it's not pushed on GitHub yet. I'm going to put it at the end of this class. What else? This list bookstore books. So I want to list local books, like the books I have in my locker. This is going to be a read function. And it's also going to return an array of books. So this one is a contract, so have no fear. Pub mode student local. Compiler will shout that I need a storage or not. I'm not going to wait for it to shout. Pub struct storage. And I'm going to say books. Sorry, pub books. Like, okay, the books in my local. Let me say this is not that smart yet. I'm going to get the type storage map storage pointer. I just like to get everything in the beginning. Read access, write access, and entry. So I'm mapping an ID to a book, which is a U8 to a book. And I have to import book here. So use super book. I'm going to save the student address, and it's going to be a contract address. So I have to come here, use Starknet contract address. What else do I need to save? Yeah, I don't think there's another thing. I don't know why the compiler is shouting at me. Oh, this is not supposed to be a semicolon, at least, or at most, if I want to put anything in a comma. So the next is events. and I have to derive the appropriate traits. Starknet events.
So,
What was your question?
sorry, sir, that your contracts are just why shouldn't it be in semicolon?
Sorry?
You change that contract address to a comma instead of semicolon. You say it
Oh,
should
I've
be a
changed it.
semicolon.
I've changed it. It's my
Is there a reason?
it's my network that my network has not registered it. Like I've changed it here already. You have not seen it, because do you understand?
I've seen it.
Ehen. There is actually latency in transmission, but you can hear what I'm saying now.
He's asking what's the reason why you change it from comma to from
Oh,
semicolon
okay.
to
He's
comma.
asking why I changed it.
Yeah,
Oh,
Yeah.
because this thing is like an object. This is not a line of logic. Do you understand? A line of logic ends with a semicolon. That's not returning
Yes.
something. But here, I'm defining properties of this storage struct. So after each property is a comma. It's just like after this book here. If you look in the line above, after this map, I put a comma before student address. Do you understand? The same way, in this borrowed book, after book ID, I put a comma before timestamp. Are you following?
Okay, sir. Understood.
Are you sure? Or you just don't want me to keep talking. You want to tell me to shut up.
Kind of.
Oh, you want to tell me to shut up. Wow.
Ah,
No.
no,
ah,
sir.
ah, ah, ah.
No, sir. No.
Okay. So inside this, I'm going to say borrowed book is borrowed book, and return book is return book. So the next thing I'll do is my constructor. And this is contract states, students will be a contract address. And I'll say self.student address dot write students. Then ABI embed v0 students local of. Let me just show you another pattern. I student local. Yes, this is also possible. Previously, I'll go up here and import student local. Like I'll say something like this. I student local. So import the interface. But I just did this to show you that I can actually reference it directly from here. Do you understand? Oh, Bernadette is bored. She has left the meeting. Bernadette. Okay. So another something. Okay, let me change this to contract state first. Change this and change this. Yeah, another thing I forgot to do is I'm going to store the bookstore address because the student needs to know where the bookstore is, right? For him to buy something. I mean, even if he wants to order online, he needs to know their websites. So, something for cross-contract interaction, there is this thing called a dispatcher. Now, when you write a trait, it's a trait. When you write an interface, it generates some things for you. Like if I come here now and I pretend I want to import some things, just watch. What I wrote up is ice then local, but just watch. Use super. Look at it. It has dispatcher. It has dispatcher copy, dispatcher implementation, set, store, subpointers. It has all of these things that it has derived for us. Do you understand? So what's this? Just look, it's plenty. It's plenty. What this dispatcher does for us is it's sorry. What the dispatcher does for us is that it helps you to be able to call that particular contract that implements the logic from another place. So to interact with this my bookstore now, what I'm going to do is I'm going to call the bookstore dispatcher. So I'm going to say create because create is easier to remember. Contracts, bookstore. I'm going to import iBookstore dispatcher. Is anybody following me? Is anybody following me? Does anybody have any question? And then I'm going to import iBookstore dispatcher traits. There are some things here that I myself have never used. So if I'll still like to check them out. But this is how, like this now, I can call the functions that belong to the bookstore. So when I want to list the bookstore books, I said dispatcher enables us to call the functions that belong to another module, be that module a contract or a component. A dispatcher helps us to call it from another place. So let's dispatcher contract. Sorry, let bookstore contract or let bookstore is equal to iBookstore dispatcher. Then I'm going to put the contract address. So this dispatcher is just derived from the interface. And if you really listen to what I explained back in week 3, this thing is just should I say a way of calling the API. It's a way of referencing the correct API. There can be different contract addresses. So when you call a dispatcher, you have to call an appropriate address that has that particular interface. So let bookstore address be equal to self dot. Remember that I recorded the bookstore address here. So self dot bookstore address dot read. Do you understand? Yes, you do. Because I believe in you. So the contract address here is going to be the bookstore address. Now I can use this now to call the functions on this bookstore. So in order to list the bookstore books here, what I have when I want to list the bookstore books, what do I need to do? Books, right? And there is no argument. It already returns an array of books. So I can just say bookstore dot get books. Do you understand? Once I call this now, what it returns is an array of books, and that's what I want. So I can just instead of assigning it to a what's it called? Instead of assigning it to a variable and then returning it, I can just call this here like this without a terminal semicolon, and it returns my array of books. Who has a question? Someone is confused. All your confusion. Does everybody understand what just happened here now? Do you understand what just happened here now? Okay. My battery is giving us 24%.
You don't have a,
Sorry?
well, since you don't have battery.
I think I can finish this. Oh, I will not finish this. I'm just going to call. I'm just going to call. What's it called? I'm not going to import the functions. I think I'll even leave it for you to complete.
Ah,
Yes, I'll leave it for you to complete. I'm just going to explain it again. I said a dispatcher, what you use a dispatcher to do is to call functions from another module, be it a component or a contract. Am I right?
yeah.
It's basically from another contract, since components are still going to be embedded within contracts. So in this place now, sorry, here, I said that you need to record the bookstore address that you are calling, like the bookstore that you are going to be patronizing. You need to have their address in your storage, right? Then when you come down here, you can just say let bookstore address equal to save the bookstore address. You have the bookstore address now. Now this dispatcher is derived from an interface. So what interface does is that it contains function signatures, right? It does not contain their logic. It's just like a blueprint. So when you want to communicate to another model, it has to be deployed on a particular address for you to actually communicate with it. So now, since you have that address stored, you can just establish communication with the bookstore by saying, let bookstore equal to, you are going to use the bookstore dispatcher, and then it has one argument. It takes in one argument, which is the contract address. And then as the contract address, you are going to supply this bookstore address that you got here. Do you understand up to this part now?
Okay.
Once you do this now, you have access to all the functions that the bookstore contains. So if we want to list the books the bookstore contains, when you come here, according to the functions here in the bookstore, to get all the books, you just need to call the function get books, right? And it returns an array of books already. And in the same way, what we need here is an array of books. So instead of we actually don't need to assign this to any variable. You can just call bookstore or get books, and this returns an array of books. And by leaving it here without a semicolon, we are returning it from our own function. So if I deploy these two contracts now, you are going to see that what this function returns is exactly the same thing as what this function returns. Do you understand?
Yeah.
Very good.
Thank God.
Okay. I think we are going to have to complete it tomorrow. My
Okay.
battery is saying no, but this is the next thing we are supposed to handle this week apart from cross contract interaction, and then we are going to do one coding session apart from this one. We are going to do another coding session tomorrow. I think tomorrow's class might be a bit long, but yeah, we have the topic for this week is advanced smart contracts writing. So we are going to be looking at all what we are just looking at is the different techniques, different things that you are going to need when you're writing real world smart contracts. So the video of this, I actually don't have battery to get the video done. So I'm going to also do that tomorrow. That's the recording of this particular class,
Yeah.
right? So I don't know. I'll push this to GitHub now, and
Okay. Yeah.
I want you to go over it, go over what we've done. Okay, this what we did today is basically what we've done on Monday, plus this interaction. So I'm going to push this to GitHub, and then I want you to go over it. Any question you don't understand, don't hesitate to come to my DM. I'm almost always there to answer your questions. I said almost. So good night. Have a nice sleep if you want to sleep, or a nice study if you want to study. GM everyone.
Thank you, sir.
Uh,
All right. Good night, everyone.